All right. Now, for section 1.6 and 1.7, we start getting into the nuts and bolts of what we're doing in algebra functions and data analysis. Now we're going to start talking about functions. Okay? So first of all, we need to know a couple of things. A variable. Okay? Everybody knows a variable is a letter. Whoops. That represents a value. Okay? Remember, x can be 3 and can be 2, whatever. Okay? A letter that represents a number. Okay? Now, we have this thing called output. Well, output is the result from a function. Okay? And on the opposite of output, we have the input, which is what we put in. The function. Okay, so we have input and output that we're going to be talking about. Usually, we consider the input an x value and the output a y value. Okay, that's going to be important. Remember that. Okay. Next, we have this thing of independent and dependent variables. Okay. Independent is the input, which we will call our x's all the time. Okay? Dependent is our output, because whatever we put in to it will depend on what we get out. Okay? Or what we get out depends on what we put in. There we go. Okay? And that will be our y. Okay? So dependent depends on what we put into it. Okay? Now, relations. Is a set of any coordinates. Okay? So an example would be, funny squiggles, 3s and 6 with 4 and 2 with -1 and 8. Okay? That would be considered a relation because it's a set of coordinates. Okay? I have more than one set of coordinates here, so I consider this a relation. Now, a function is a special type of relation. Okay, it is a relation with a one-to-one association. Okay, what that means is there can't be any repeat in the x. Okay? So if I'm looking at my relation up here, is it a function? Well, look at the x values. Where are the x values? X always comes first. Okay? X comes before y in the alphabet. X comes before y in a function. Okay? So are there any repeats in my x? No. So that means this is a function. Okay? Now, if I had a repeated x, then it wouldn't be a function, it would just be a relation. Okay? We're going to be looking at functions from here on. So keep in mind, function. Alright? Now, we have a representation by numbers. So we call it a numerical representation. Okay? And with this numerical representation, it's just that. It is using ordered pairs. It's using numbers. Okay? So 3, 6. The x is 3, the y is 6. There's the numerical representation. Okay? Now, the fun part, the coordinate system. Okay? Let me see if I can get a graph up here for you guys. Here we go. Now you're going to do an activity in class that's going to be dealing with the coordinate system here, okay? There we go. Let me move this. Move that out of my way. Okay. Now, the coordinate system. We have, for our coordinate system, an x-axis and a y-axis, okay? And we have 4 quadrants. And you're going to do an activity that will help you remember all this, okay? But come in with this information. This is quadrant 1, okay? The uniqueness about quadrant 1 is your x is positive and your y is positive, okay? So no matter what, when you have x and y that are positive, they go in quadrant 1, okay? Quadrant 2. Here, your x is negative and your y is positive, okay? Anything above the x-axis, it's positive for the y. Anything below the x-axis is negative for y, okay? Anything to the left or to the right of the x-axis or y-axis is positive. Anything to the left of the y-axis is negative, okay? So, quadrant 3, both x and y are negative, okay? And the last quadrant, your x is positive, your y is negative, okay? They go in a counterclockwise rotation, one always starting up in the upper right-hand corner, okay? Now, if I am on the x-axis, my y will always be 0, no matter what. 0 for y when I'm on the x-axis. Now, when I'm on the y-axis, it's going to be 0 for x. Okay? So whatever my y-axis is going to be, where it crosses the y-axis, we'll have a 0 for x. Important things to know. Okay? And again, we're going to do an activity that will help you remember all of this. Okay? Next thing. Practical domain and range. Okay? First of all, the domain is the x values. So don't let that fool you. It's just all the x values, all the x's that we have, okay? Range. If it's not the x values, it's the y values. So don't get those confused, okay? It's easy enough. Range x, domain x, range y. Okay? Now, practical means think about it. If I have something that has a limit, okay, say I can only spend $300 in a week. I'm not going to spend more than $300. I'm going to spend that $300 or below it. Practical domain, okay? Practical range. So it's got to fit into the limits, all right? So 300 per week, okay? No more, no less. So the 300 would be a range, okay? Because that's the maximum I can spend. So that would be on an x-axis, okay? So your domains are always on the x. And your range is always on your y, okay? So keep that in mind, domain and range. Function notation. A lot of people have a hard time with function notation, and you shouldn't. You shouldn't let it scare you. It's just notation, okay? If you have y equals 2x plus 3, we all have seen this before. It's slope-intercept form, okay? Function notation just takes this thing called f of x and puts it in place of the y. So now my function notation is f of x equals 2x plus 3. Has the 2x plus 3 changed? No. What has changed? I put f of x there instead of y. Okay? So instead of having a problem that says, evaluate y equals 3x minus 1 for x equals 6, okay, that's still a long sentence. I can just say, find f of 6, where f of x equals 3x minus 1. Okay? Same thing. They say the same thing. You do the same thing. What do you do? What is it you do with this? It's plug and chug, folks. It's what I call plug and chug. You put your number in. Where you see that 6, you put it where the x's are. So for the y equals, it's 3 times 6 minus 1. Do the math. Chug it out. 18 minus 1, 17. How is that different than this? It isn't. If I have f of x equals 3x minus 1, I want f of 6. Wherever I see this 6 is where I'm going to put it for the x's. Okay? So f of 6 is 3 times 6 minus 1. Again, 18 minus 1, 17. Okay? No difference. No difference at all. Alright? So think about that. Come in with some ideas. And we will be doing a coordinate system activity when you come in for one of these days. Okay? So think about that. Please don't let function notation screw you over. Alright? Think about it. It's no different. F of x, y, same thing. Okay? Take care. See you in class.